Good morning, everyone. I am Trish Demeter. I'm the Managing Director of Energy and Clean Air Programs for the Ohio Environmental Council. I also facilitate the Ohio Coalition for Combined Heat and Power, which is a voluntary coalition that seeks to promote CHP and waste energy recovery technologies. We also work to reduce barriers and advocate for policy solutions to increase project deployment in Ohio. The title of today's webinar is How can combined heat and power help Ohio achieve its carbon reduction goals, specifically in the Clean Power Plan, is what we'll be talking about today. In our agenda, you'll see here on the screen, I will do a quick introduction. Our first presentation will be all about how the Clean Power Plan treats combined heat and power technologies. How does the final rule consider CHP for states as an option to help them reduce their carbon emissions. The second presentation will get more into the specifics about how Ohio can use CHP in its state implementation plan for the Clean Power Plan as the state of Ohio works to develop that plan. We will end today's webinar with about 15 minutes of questions and answers. We will do that through the type-in chat box. We'll get to the specific instructions later on in the webinar on how to do that. We appreciate everyone's participation today. Thank you so much for joining us. The reason we wanted to do this webinar is because combined heat and power is an efficient technology with huge potential in the state of Ohio, and it also has a huge impact on reducing carbon emissions. In the state of Ohio, there is about 9,000 megawatts of CHP potential in the state, given our heavy industry and very intense big users within the state where CHP is a good candidate. 9,000 megawatts, to put that in perspective, is the equivalent of electricity produced by 18 conventional power plants. So the potential is huge. How do we harness that? Nationally, we compare to about 84,000 megawatts of installed capacity at 3,500 sites. These are sites that represent about 8% of the total US electric generation capacity. And through those sites, it's annually eliminating over 400 million tons of carbon dioxide emissions each year. So the potential for CHP to really help Ohio reduce carbon emissions is big. So with our speakers, I'll get to introducing our speakers here. We have two fantastic presentations today. Jennifer Kiefer will be up first. Jennifer is the Vice President of David Gardner and Associates. She has 12 years of tremendous experience with legal and political expertise working on climate, energy, and other environmental issues. She manages David Gardner and Associates' work for the Alliance for Industrial Efficiency, which is a coalition of labor, contract association, businesses, and environmental groups to advance manufacturing competitiveness through the use of CHP. Our second speaker will be Megan Kelly. Megan is a senior research analyst for the industry program at the American Council for an Energy Efficient Economy, ACEEE, in Washington, D.C. She conducts research and analysis, and she does outreach on energy efficiency policies. So with that, Jennifer is up first. Jennifer will dig into how CHP is treated in the final rule of the Clean Power Plan and give us a great run through of how, mechanically how this could work here in the state of Ohio. Then Megan will dig in more to the specifics on how this could work here in the state of Ohio. So Jennifer, the floor is yours. Jennifer, we have unmuted you on our end. Are you muted on your end?
I sure am. Can you hear me now?
Yes, I can hear you.
Thanks so much. This would have been a very boring webinar if we didn't catch that.
Right.
Sorry, y'all. In any event, thank you so much for convening this group and for inviting us to present today. As you heard from Trish, I'm going to go ahead and kick things off. Let me just give you a bit of an outline of what I plan to cover for the next 20 minutes. Then we'll be pivoting over to my colleague Megan Kelly at the at ACEEE. I'm going to be opening up with kind of why it makes sense to talk about CHP in the context of the Clean Power Plan in the first place. I'll be talking a little bit about its benefits and really focusing in on the greenhouse gas benefits of CHP. I'm then going to put it in the context of the Clean Power Plan, talking a bit about the timeline, where things stand and how CHP might actually fit into this process. Highlight some of the changes from EPA's proposed rule for those of you who may have been following from when the rule was first proposed in 2014 to the final rule, which was released late this summer. And then we'll talk a bit about the treatment of CHP in the rule. And when we talk about the treatment of CHP, there's really kind of two buckets. There's the treatment of very large affected units that are effectively utility power plants themselves. And then there's what I think of as a much more exciting opportunity for non-affected units to help Ohio meet its compliance targets. I'll begin that discussion, but be turning to Megan, who will really focus in on how the role that CHP has to play in Ohio. So with that, let's go ahead and get started and why address the question of why does it make sense to talk about CHP in the context of the Clean Power Plan. My first slide here, I'm having some trouble with advancing. There we go. My first slide here illustrates kind of the broad brush of what is the Clean Power Plan. On the left here, you've got your power plants, and we are looking through the Clean Power Plan, which is under Section 111D, as in dog, of the Clean Air Act, to reduce emissions from power plants by 32% by the year 2030. That's that red line on the graph here. And EPA has given tremendous flexibility to states and EGUs to determine the best way to reduce emissions. So that's why you've got all of these different things coming into play on the right side of this graphic. You've got renewables like wind and solar. We have energy efficiency, which not only includes things like your lighting enhancements, but also includes combined heat and power. And then, of course, there's also heat rate improvements at the utilities themselves. But it's because CHP can help reduce greenhouse gas emissions that it makes sense to talk about it in the context of the Clean Power Plan. And you could see that benefit depicted here in this next slide. I use this graphic in virtually every presentation that I give. It's very simple, but I think it makes kind of the key point about why CHP should be part of the conversation. Conventional power generation is incredibly inefficient. It doesn't matter what kind of fuel you're talking about, whether it's coal or gas, hydro or nuclear, any fuel input, you're losing roughly 60% of that fuel as wasted heat out of the smokestacks at your power plant. And if you're talking about central power generation, the loss doesn't end there because you need to get that electricity from the central power plant over to the homes and businesses that are using the electricity. So on average, nationwide, we're looking at 7% line losses in the transmission and distribution of power to get it over to your end user. So that at the end of the day, less than 1/3, about 33% of our electricity, our fuel inputs, are converted to useful electricity. Now, combined heat and power turns that inefficiency on its head. So that in the case of waste heat to power, you're capturing wasted heat and using it to generate additional electricity. And in the case of CHP, you produce both heat and electricity from a single fuel source. But in either case, 2/3 of the inputs, actually higher than 2/3, are converted to useful power for end users. And when you enhance efficiency in that way, you're reducing emissions. Less fuel that needs to go into the process, less fuel that needs to be burned. That means that there's lower carbon emissions coming out of it. And as you'll see on my next slide, that fact is not lost on EPA. This is a graphic that many of you are probably familiar with. It's from EPA's Combined Heat and Power Partnership website. On the left-hand side here, you've got conventional power generation. So you've got your power plant up top, and as we said, it's fairly inefficient, operating at about 33% efficiency. But you also have a separate boiler on site producing heat and hot water. Because of the relative inefficiency of conventional generation, you're looking at 45,000 tons per year of emissions in the production of heat and electricity. In contrast, for CHP, you have significantly higher efficiency, and as a consequence, much lower emissions. You're looking at, according to this graphic, 23,000 tons per year. Now that benefit is very large when you bring it out to scale. As many of you are probably aware, a few years ago the administration issued an executive order, and they issued the challenge of increasing CHP deployment by about 50%, or 40 gigawatts of new CHP by the year 2020. And alongside that executive order, DOE and EPA issued a report in which they said, if we realize that goal, we will reduce carbon emissions by 150 million metric tons. A more ambitious scenario by Department of Energy in 2008 said, well, what if CHP were to provide 20% of electric capacity, about a doubling from where we are today? And they found if that goal were realized, you would cut carbon emissions by 800 million metric tons per year, or the equivalent of removing 1/2 of the passenger vehicles from the road. So clearly there's tremendous greenhouse gas benefits that come with full-scale deployment of CHP. And as I said, EPA is well aware of this. In issuing some Energy Star awards for a CHP project about a year ago, Administrator McCarthy declared, the CHP technology offers a strategy to help meet the goals of the President's Climate Action Plan for a cleaner power sector while boosting the efficiency and competitiveness for many U.S. manufacturers. Now, my guess is that for lots of the folks on this line who are involved in the installation and design of CHP systems, it's those manufacturing competitiveness gains that are the real reason why CHP is attractive, not necessarily just the environmental benefits. And those gains are significant. Of course, the less fuel that goes into a process, that's less money that needs to be spent on electricity and more that can be put into the bottom line. There's tremendous job opportunity in the design, the construction, the installation, and maintenance of CHP equipment. And the facilities that are using that equipment are more competitive so they can hire more employees. The additional economic benefit of CHP is depicted on this next graphic, which demonstrates that CHP is a very cost-effective way to reduce greenhouse gas emissions. So across the x-axis here, you've got the levelized cost of electricity. Across the y-axis, you've got a long list of clean energy sources. And I don't expect you to read through all of them. The key thing I want you to note is that at the very bottom and left, we've got natural gas combined cycle turbines with CHP. In other words, CHP is one of the lowest cost ways to reduce greenhouse gas emissions. In fact, that DOE EPA report I mentioned that came out a few years ago shows that CHP can reduce carbon emissions at less than 1/6 the cost of distributed solar and about half the cost of wind. So again, this is really something that should be part of the conversation when we're trying to figure out the lowest cost way to reduce emissions and comply with the Clean Power Plan. So where exactly does CHP fit into the plan? To get to that, I want to first address just kind of where we are with the planning process itself. I'd mentioned earlier that the rule was first proposed in 2014, so that's slightly to the left of this timeline here. EPA then received 4 million comments on the proposal and finalized the rule this past August. It was published in October, and there's still a few loose threads about the model trading rule, federal plans, measurement and verification guidance that EPA issued. Those things have a comment deadline that's due this coming January. I'm working along with the Ohio Environmental Council to develop comments, and we'd be delighted to share with folks some of our thoughts about how to improve the treatment of CHP in that plan. But in any event, finalizing the rule in August now starts the kind of timeline for its implementation. And states will need to provide an initial submission that at least has kind of the rough contours of what they're planning to include in their plan, and potentially a request for an extension in September of 2016, with final plans being submitted beginning in 2018. Now, initially, the targets went into place as soon as 2020, but in this final rule, EPA pushed that back a bit to 2022. And as you'll see from these green bars, there's kind of a glide path to compliance between 2022 and 2030, with every 2 to 3 years having intervals of increasingly more protective standards until we achieve that 2030 goal, which, as I said before, is 32% reductions nationwide for carbon emissions. You see that little hatched box between 2020 and 2022? That's the Early Action Program, the Clean Energy Incentive Program. Right now, the way it's written, CHP has no role to play there, but we did file comments just this week urging EPA to expand the list of eligible resources for early action credits. And so we're hopeful that CHP may be able to help with some of that early compliance as well. Now that's just, that introduction of that clean energy incentive program is just one of the changes that came with the final rule. I want to spend just a few minutes talking through some of the other changes between the proposal and the final. First, there's a more ambitious target. So the proposal was looking at 30% nationwide reductions, and as I've said, the final rule is looking at 32% nationwide reductions. There's also the shift in the compliance timeline I mentioned, bumping it back from 2020 to 2022, though we're still having kind of the final targets in place by 2030, so it doesn't shift the end goal. But recognizing that push out in the compliance timeline, EPA also was providing an opportunity to help incentivize things that are kind of particular priorities for the agency. And those include wind and solar, and then also energy efficiency activities in low-income areas. And as I said, to date, that does not include CHP, but we're hopeful that that might be expanded. We filed comments on that earlier this week, but there's also an opportunity to weigh in on the kind of scope of that early action program in the January comment period. There were also some changes to the building blocks. So the proposal had 4 building blocks, which were then used to set state targets. And those included energy efficiency, renewables, changes in heat rate improvements at the plant itself, and then fuel switching from coal to gas. In the final rule, they dropped the energy efficiency building block. Now that sounds like it's really significant, especially when we've got a webinar talking about energy efficiency. But EPA makes it abundantly clear in the rule itself and in all of the supporting materials that energy efficiency is still a key compliance mechanism and still has a role to play when states are shaping their plans. So now there's only 3 building blocks, which EPA used to set a national target for coal and gas plants, and I'll talk about that a bit on my next slide. They then clarified allowable energy efficiency. It was clear even in the proposal that CHP and waste heat to power were eligible, but that and some other details about what constitutes demand-side energy efficiency is spelled out in the final rule. There's a greater emphasis on trading programs. So in the proposal, if you wanted to trade, you had to tell EPA that you wanted to trade up front and let them know who the potential partners were going to be. Now, any state that has what's known as a mass-based plan will be able to trade with other mass-based planning states, and any state with a rate-based plan can trade with other rate-based states. And Megan will provide some more detail about what that means exactly. But there's kind of this preference for trading that's indicated in the final rule. Another reflection of that is EPA issued a model trading rule, or a proposed model trading rule, again, to provide kind of a presumptively approvable plan that states might be able to use to facilitate trading. And then finally, the final rule addresses federal enforceability, making it quite clear that even if you have a state approach, that at the end of the day, it's the EGUs that are on the hook. And so there will always be a backstop against the electric generating units. So I'd like to turn now to what the targets actually look like. There were some changes made to target setting between the proposal and the final rule. So let me walk you through this graphic and the next one, which explains that process a little bit. So EPA set uniform national targets for steam plants, or coal plants, and also for natural gas combined cycle units. Ultimately, for coal plants, as they're depicted in the black, we're looking at 1,305 pounds per megawatt hour of carbon emissions. And for your gas facilities, which are cleaner, we're looking to get down to about 771 pounds per megawatt hour. And as you can see from the little boxes there, there's a glide path to get you to those reductions. Now, it's a uniform standard for all units of a particular type, but that plays out differently in each state dependent upon its fuel mix. And you see that depicted here on my next slide. So I don't expect you to be able to read all of this now, but there's a red arrow by Ohio's standard. And so as you can see, for a state like Ohio, that's got a pretty coal-intensive fuel mix, its end target is going to be a lot higher than a state like Connecticut or Rhode Island on the right end of this graphic. So at the end of the day, by 2030, Ohio will need to reduce its emissions by about 36% to get down to 1,190 pounds per megawatt hour. So this is kind of, not the most aggressive standard in the country and not the least aggressive standard in the country. So what I'd like to turn to now for the latter part of my remarks is how exactly does CHP fit into this rule? We've already addressed the fact that CHP should be part of the conversation because it has clear benefits for reducing emissions. Now there's two categories of how we think about CHP in the context of the Clean Power Plan, as I said in my opening slide. What I'm going to cover now is the treatment of CHP at affected units. And the reason that's relevant is because there are an awful lot of existing CHP units around the country. You see that on this slide here. There's 4,300 existing CHP systems in every state in the country with large concentrations of